you can hear me. So we'll start. We're going to look at handling data in R today. We look at handling vector data, raster data, tabular data, some aspects of cleaning data, mapping data, and also look at some of our available courses and the training that we currently offer. So, of course, we're doing GIS, so it's a GIS webinar. We're going to look at handling data in R. So for the overview, i.e. now what we're going to discuss, as I've already mentioned, we have the brief introduction to R's features, which is a programming language. We have now the overview of vector data, tabular data, raster data, some definitions, calling data, cleaning and organizing mapping, and then the available courses. So now we look at some features of R programming. R has a wide array of packages. You can use packages to call vector data, now raster data, tabular data. You can use different packages when you want to map, to animate, like ggAnimate. Then it also handles all sorts of data, as we've already mentioned. It has various graphical libraries, fast calculation, comprehensive language, and then it's also open source. I hope you can all see my screen because there's something being, if you can't see, just raise your hand or something. Yeah, thank you. Okay. So now we look at the overview. We look at different types of data, the tabular ones, the vector and the raster data. Now, when you're looking at data, if you've ever interacted with something like Microsoft Excel, you can know that that's tabular data. It's arranged in a tabular structure. And then vector data is something that contains lines. We have the points, we have the polygons, and then now raster data for continuous surfaces. For example, if you've looked at data for precipitation, temperature, rainfall, land cover. And then for your vector data, you have things such as roads, you have your power lines, you have your rivers, you have your lakes. So polygons, now that can represent things such as lakes, buildings, but you have to realize that you can represent data in different ways. For example, a building can be represented as a point and as a polygon. It depends on the scale that you're using for your data. If you look at the overview here, we've explained that there are different data used to represent the geographic information. And then now some differences and advantages for the vector and raster data. You can notice that when you're using your vector data, for example, you want to zoom into schools in a specific county. If I zoom to the highest level, like I want to look at this county, this sub-county, this ward, I can still see the school at a precise manner. Now, the difference between the vector and the raster data is that if you decide to zoom raster data, you know that raster data is represented by pixels. You'll find that you might lose some information as you continue zooming. Now, that's where the aspect of resolution comes in. You look at aspects such as spatial resolution, spectral resolution. For example, you have satellites that have 10 meters, others 30 meters like Landsat. And you know that for the resolution that you're using to view your image, the more that you zoom in, you might lose some details because something is aggregated to, let's say, that 30 meters, that 10 meters. So you'll find that if something, let's say, has a resolution of 10 meters versus 30 meters, you'll expect yourself to see more in the 10-meter image, like the one that has the resolution for the 10 meters. I've given a brief overview, but then the slides will also explain more on this. Okay, sorry, I've skipped ahead. Okay, let's see. Okay, so now you can see here what I was explaining during the overview. You have your tabular data. It's used to store descriptive information known as attributes about geographic features. And then it's organized in rows and columns, similar to a spreadsheet. There I was mentioning you can use your MS Excel. Now you can have this tabular data representing things such as population. For example, you can have a table that has your population by sex, i.e. female, you have male, you have the total population, you have people who are under the age of 18, above the age of 18, between a certain age group, i.e. 60 to 80, so that it can help you make an informed analysis if you decide to do either visualization or analysis for any purpose. Because you know that when you're using your GIS data, there you represent it to different clients, or let's say even in a project, in your school project, you'll have to understand what you're mapping in the first place. So for example, if someone is interested in only the female population, if I'm too fast, please someone just type in the comment and one of my colleagues will alert me. Okay, so if you're mapping, let's say, something for people under the age of 18, let's say your client or the project that you're doing is involving people who are under the age of 18, you want to know the children that are available, you want to know the households that are available. Use your tabular data to get all these records, i.e. by city, by county, by sub-county. So from this image, I hope you can see my cursor. Yeah. From this image here, you can see that we have the county. Now, these are the records, like Mombasa, Nairobi, Machakos, just as an example. You can see the total population, think for 2019, the census that was carried out, and then the female population, and then the male population. So each row or record can correspond to the specific geographic feature. For example, now let's say we have this tabular data here like this. We can link it to our vector data and say that once you're mapping, let's say that county or country, whichever, you can find that now you know the population. Now from there, you can make the dot density maps, you can make the proportional symbol maps, where you use different shapes to show the number of people who are available in such a county or such an area. Or you can also look at different aspects, even people who are performing the highest in a specific grade, you can still map such data. Okay, then we'll move forward to vector data. So vector data, as I had explained, we have the points, you have the lines, and then we have the polygons. They're defined by a series of geographic coordinates, X, Y, sometimes Z, and this makes them ideal for representing distinct features with clear boundaries. For example, when we're saying that it helps, okay, please mute yourself, thank you. When we're saying that it helps represent distinct features with clear boundaries, think of it this way. You can't necessarily say that soil, let's say you're looking at the soil for which area? Kiambu. And then now you want to represent that at this point, the soil is clay. At this specific point, the soil is loam. And then at this specific point, the soil is sand. Because you'll expect that if an area has clay soil, it's continuous until a certain point where the soil starts changing to a different soil type. Now, for the distinct features, you can have something like a school. You won't expect to find your school being continuous, i.e. this school starts from here and then continues throughout this county and then the next county. You'll find that it's distinct, i.e. it's represented at that specific location, either with your polygon boundaries or as a point, again, depending on scale. Let's see. So you can see this image here. We have now the points, the lines, and then the polygons. You can say, let's say this is a road somewhere, or access points. You can say this is a farm, whichever way you can use to visualize the difference between your points, lines, and polygon features. Okay. Let's go to the next slide. So we look at raster data again. So raster data, as we had mentioned again, it represents continuous features as a grid of pixels or cells. Each cell in the grid has a specific value. Let me share the image so that you can understand this better. Now, if you look at this, this is an image, right? If you can look at, I hope you can see my cursor. If you can look at this area where it's been zoomed so that we can see it in a wider perspective, you can see that this is maybe a road or a bridge. This is a river passing somewhere. And then this is all pixels, right? But now when you zoom, you can see that this area is mostly inhabited by this specific color code of pixel. Now, when you're looking at raster data, you'll find that the pixels correspond to specific things. For example, if I'm doing land cover classification, and then you have things that you've classified as crops, others you've classified as built up area, you'll find that you've given a specific color scheme to your different crops, your built up areas. So when you zoom into that pixel, you can accurately tell what you're supposed to be looking at. I hope that's understood. Okay, so now we look at calling data. I will first do the overview, then we'll head over to R because it would be easier to present it. And then now we look at the aspect of R, but it's almost the same thing. Okay, so tabular data is the most straightforward to handle because it's in the native format. R will read your object as a data frame, table. Let me do this. Let me head over to R, but that would take some time. Okay, let's first finish here. So this is something that I had already run in R. I'm going to show you with the R Studio as well. So you can see that we read this data into R like a data frame. So you'll have your rows and your columns. You can see that we have the temperature, humidity percentage, is it protected, which species is this? You can see all the names and then the IDs. You'll find that in most times when you're handling GIS data or basically just any data that needs to have an identifier, it needs to have a specific unique ID that you can use to call that specific record. Because you'll find that if you don't use the unique IDs, you won't be able to necessarily call your specific data. You can find that something else has an almost similar name, but if you had differentiated it with your unique ID, it would have been better to select that specific record. So key functions, base R functions like the read CSV, these are the comma separated values, then the read table, then read Excel also. You can read an Excel file into R. Okay, that's also another example of the table that was read. And then now you have your vector data. Vector data is normally handled by packages such as SF. You can use the stread from SF to read now your vector data. This mapping is an example of data that was called into R and read into R as a vector data using the SF package. And then we have raster data. It's handled by the raster packages. Like if you remember when we started, we mentioned that you call them with different packages, as R has a lot of packages that are suitable for handling different types of data. So you'll have your packages for calling your raster, your vector, your tabular data, and then you can work with all of this together. For example, I can decide to call raster data and then clip it or mask it to a vector boundary. For example, if I want to look at the rainfall or soils in a specific county, I can load the soils data, no rainfall, because soils it can be, okay, it depends on how you look at it, but for the rainfall, for example, you can load that data from charts image or even from Google Earth Engine. You bring it to R to help you now to clean it or to analyze it further. So you can have the raster function, which reads data. Yeah, we'll share this PowerPoint. Yeah, we'll share the PowerPoint. And then now this is raster data that was loaded. This was the mean temperature. It shows a raster of Africa's mean temperature loaded onto R. Now here you should note that we've only done loading. As you can see, we'll need to clean this data because if right now someone asks you, so what do you expect to be the temperature at, let's say Kenya or Ethiopia, you can't necessarily tell because we have the outlying values, right? But we'll look at that as we go on. So now from here is when we talk about the cleaning aspect, how you can use R, remove your outlier values using thresholding method. Yeah. So we look at at cleaning and organizing data, some of the basics. So you'll realize that in anything that you do, you have to first clean it. For example, even when you're going into a house, you have to clean it first. You can't just start using it as is, because there's some aspects of arrangement, standardization that need to be done. So cleaning and organizing data, you have that data is often raw, messy, and you have to standardize it so that you can use it for analysis, mapping. For example, you can have your tabular data, let's say in Excel, and someone writes Nairobi as Nairobi without the I. Okay. And someone writes Nairobi without the I. And then you know that this can be taken as a different record when in reality, this is actually Nairobi. So you will look at that tabular data, you correct your spelling mistakes for the names, you standardize the data formats. For example, if someone had been collecting my data and storing it in meters, someone else in centimeters, someone else in feet, you have to standardize that data so that now it can be compatible and you can use it across different sources. And then also looking at aspects such as the coordinate reference system, you have to standardize that, i.e., if one dataset is in a different coordinate system, you have to make sure that all of them are in the same one. And you can look at some software like QGIS. We have the on-the-fly projection. It's automatically done for you. So it will automatically project it to the first layer so that you can visualize your data. But then you still have to confirm if your projections have been done well, right? Okay. And then we also have the data structuring and linking. For example, if now you're working with your tabular data and then you want to link it to have a spatial aspect, because you know that most tabular data, you won't necessarily have to have it having the XY coordinates. Like we saw before, you can have the Mombasa County and then you're given the population in female, male, under 18, above 18, this specific age range. So you have to link it to the vector data to give it that spatial component. That's all under the cleaning and organization of data. Now for vector data, for example, consider something like digitization. When you do digitization, there are some errors that you have to check for. You can look if your digitized points, let's say the polygons, they have gaps between them. Are the roads crossing, let's say, boundaries that they're not supposed to be crossing? For example, you can't expect a road to be crossing right in a school. That means that you've done something wrong. So you have to clean and organize your data before you finally use it. If you look at the screen, there's okay, it's basically an overview, but you can see that it's a systematic process of identifying and correcting errors, inconsistencies, and redundancies. For example, redundancies is just when you have repeated data for the same specific thing, i.e. Nairobi, someone had written Nairobi, all that. You find that that's the same record, but written in a different way. So you now have to remove these duplicates, redundancies, so that you can use your data in a more defined format. So without this step, you might find that you've created a map, but it does not necessarily communicate what it needs to communicate. Okay, so we have, you can look at this image. We have the cleaning is done to ensure that you remove your errors. You have increased data quality, higher accuracy, efficiency, complete data. In case there are any missing data, you can look for other sources and now add data to your already existing data. And then also to maintain data consistency. Then next we look at, I think, mapping. Yeah, mapping data. So imagine you have a lot of records in your Excel file or a lot of shape files. For example, I want to map all the utilities in an area. I go and give someone all these different shape files or now your geo packages. How are they going to use it if they do not necessarily have that GIS knowledge, or if they do not know how to use the mapping software? So you now map this data. For example, if someone gives me an Excel file containing all the students performing between this grade and this grade, and someone else decides to present it to me as a chart. I'd be more inclined to look at that which is presented as a chart since it's more visually appealing and communicates faster. I do not have to look at all these records, identify which student is performing better, which one is not. It isn't the process of communicating information to a lot of people and has a wider reach. Even those who have not studied mapping can understand that chart. As long as you've done the correct visualization, you've applied the correct colors, and you've accurately used the correct data, because you can also map wrong data and then you communicate the wrong thing. So mapping is the process of creating a visual representation of geographic information. It takes both raw spatial and non-spatial data. As I had mentioned, you link your data when you're doing the cleaning process. Before you map the data, you need to clean it, format, and organize it. So the goal of mapping is not only to show data, but to reveal patterns, relationships, insights, which is not as obvious when you're looking at a table. Now, again, consider someone who has a lot of rows, let's say even 1,000 rows of this county having this specific disease, let's say malaria, and someone else is affected by cholera. You can group all the counties that have the malaria outbreak and give it a specific color. Now, if someone looks at that specific map and they're interested, let's say, in malaria only, they can highlight which counties they need to check on. Or if someone wants to look at only cholera, they can highlight. And they can also tell if you've added, it depends with what data that you've added. If you've added the correct data, they might tell, okay, this outbreak is because of inaccessibility to this specific thing, lack of access to clean water. So again, mapping visualization depends on which data that you've added and what exactly you're trying to communicate. But the essence of mapping is to communicate in a better way, to reveal the patterns that are within the data, the relationships, and the insights that might not be as obvious when you're just looking at the raw data. Okay, these are just the layers that have been showing the layers that you can add to your data. It's a visualization. So I'll look at, if you remember, we loaded let me see the slide. Let me find the slide. See where it is. Okay, here. I hope we can see my screen. Assuming that we're all fine. Could someone just react? Okay, thank you. So if you remember, we had called data. I'll show you on R as well. We had called our data, right? And then when we called it in R, we had this map of Kenya. This is how it's loaded without any visualization. If someone asks you to explain exactly what you can see from this map, i.e. which soils are present, where you wouldn't necessarily be able to explain because it's the same color. It's just data that has been loaded, right? So now that's where the aspect of mapping comes in. Let me find the slide again. Where is it? Yeah. Actually, let me show you the one for Africa. And then this is also the raster data that we had loaded. We have not visualized it at all. Okay. Then let's look at now the mapping aspect. Let's start with this one. Yeah, so now picture that initial image for the Kenya map. We had loaded soils data. If you fail to do the visualization, someone who will get that data won't be able to understand exactly what you're trying to present. But then if you decide to use different colors, the north arrow, you add the different elements that make a map a good map. This is just a basic map. You can see there's the title, we have the north arrow, you have the scale, we have now the soil drainage description. This is obtained from the attribute table. Please note that when you have your vector data, you'll always have your attribute table present. So you can look at it even with desktop GIS software. You can also look at it with R. I had shown an example of tabular data, but not now for the soils, but there's the whole attribute aspect, which you can as well look at using different functions and commands on R. So this is now the soil drainage description. We have the extremely slow, rapid, slow, very rapid, well drained, and now there's missing information. Now, if someone can look at your legend and look at the colors, they can as well try to understand what you're trying to display. Again, you can change your colors to suit whatever you want. This is just for display purposes. And when you're displaying, try to use between, if it's a hierarchy, i.e. graduated colors that are not changing completely at the same time, try to make it between 3 to 5, not more than that, because at some point, people cannot really tell the different colors if there's a lot, i.e. jungle green, you're looking at forest green. So just try to minimize that or try to use different colors to represent what you're trying to show. But then again, you have to consider the cartographic elements. You can't say you're representing a river and then give it the color black or green. You'd be more inclined to give it the color blue because you know that blue stands for water. Even if someone who's not trained to understand visualization in a GIS aspect, they'd automatically assume that this has to be something that's related to water. Or if you want to represent something like a hospital, you'll find that commonly someone would prefer using the H symbol and not something like an airport symbol. You have to consider the cartographic representation of your features, whether it's a polygon, a line, a point. Okay. So we'll have two maps here. We have now the soil drainage classification and then soil type. Again, these are just different visualizations based on the attribute table from the loaded soils data, the one that we loaded into R, which we initially saw as just grayed out all of it. You can see we have now the different titles, the drainage versus the soil type. You can notice that we're using the different north arrow. You can change how you want your north arrow to appear, the location, just like you can do in desktop GIS software. Then you have your different soil types. You have the clay, loam, sand, very clay, then again missing information. Then we look at mapping both vector and raster data. Let's see. Okay, let's start with this one. If you look at this map right here, if you remember, let me just toggle back to the other slide for Africa. Yeah. If you can see this first map here, we had just loaded the data. Nothing had been done to it. We hadn't removed the outlier values. We had just loaded it in its raw form. Then now, when you come to the aspect of cleaning, that's why you do the thresholding. I'll remove values that are from this point, because if you look at this data, of course, the temperature will also be reading that of the water body. So that's why you'll find that this map is displayed as this, because all of them seem to be between 0 to 1000, and then the rest are now the low values. So now you have to apply that thresholding, and then you have significant values that will communicate. So this was done in R. You look at the temperature in degrees Celsius in Africa. This was done there. So you look at the values. If you look at the first one, you can see that we have the value changes, i.e. the negative 1000, negative 7000. But then if you look at this one, you see that the maximum temperature that we have here is 35. So that allows your software to give the different colors for your different temperatures. And then now, when you are saying you can use both the vector and raster data, you can see that this is raster data, this Africa itself, right? And then we load the Kenya boundary. From this data here, was it cropping or clipping? Yeah, we clipped to the Kenya's boundary. And then now you get your mean temperature, highest 30 degrees, which shows a different variation. If you're looking at it from this perspective, if you try to locate where Kenya is here, you wouldn't be able to necessarily tell the variation of temperature looking at this bigger map, right? Let me share my screen once more. I'll stop sharing so that we can head over to R. But before we head over, are there any questions or is something not understood? Tom, you're looking at the chat. Is everything okay?
Yes, as for now, there's no any other questions. Maybe during the presentation, the actual practical.
Okay, thank you. Give me a minute so that I could switch between the software.
Okay, no problem.
Okay, I'm sharing my screen once more. So, okay, let me start from R. So now this is the software that I'm using, RStudio. I already opened it, but you can as well just download it, and then you have to download both R and RStudio. So I'm using RStudio at this moment in time. So this is what I have opened. I opened it before to avoid the loading time for the software itself, right? And then let's say you want to create a new script. You'll come here to File. You'll always find, where is it? Yeah. You'll always find this once you've loaded our version. It's a free software, comes with no warranty. You're welcome to distribute it under certain conditions. You'll always find this. You can type demo for some ideas, to quit R. Yes. So that's basically it. Since we're looking at data loading, I think we can just go straight to the data itself. You can familiarize yourself with the software though, because there's a lot of functions on edit, code, plots. Okay, so let's say you want to create an R script, you can just click on new R script, and then you can save. Source on save depends on whether you're just using R itself, or let's say I want to code in Visual Studio. And then now from where I had saved it is where I'm calling it back to R. So every time I'm saving it, the replacement code, if any changes have been done, they will reflect on where I'm running it. And then of course, session, you can quit your session, you can clear your workspace. Yes. You can clear all plots that you have. So we've already shown script. You can use basically the script itself, or you can use the R markdown. So for example, I give it a title, give it a different title, handling data R, nah, okay, current date, what? You can choose whichever default output format you want. I can also choose to create an empty document here, but let me just say okay first of all. And then you see the title is reflected here. And then the author is EcoSpace Services, the date, and then the output I would want to have, let's say now the word document. Then there's also the explanations, which would be good if you're starting it for the first time. It helps you understand a few things. And then you can also embed plots, etc. Or you can just come, say file, new file, the markdown, and then we can choose to create now the empty document. You'll give it the title if you so wish. Okay, so now we look at handling data in R. That's where now I've shown where this part comes from, right? Yes. Okay. So initial steps, the tutorial will give you a walkthrough on cleaning data, calling the different types of data, and viewing or visualization. So for this one, get working directory, it helps you get your current working directory, i.e. where is it that R will save your data? Where is it that it will call your data from? If you want to, I'll show you, I'll explain this part, but I'm just going to explain now the initial steps first. So you can get your working directory, i.e. where now R is calling at, and then you can also say, let's say you set your working directory, and then you'll choose now the area you want to set that directory. Let's say you'll direct it, but now I already have this path here. I had already preset it, so I wouldn't necessarily want to change, but I'll explain this part. Now let's say this is the data path, right? You have C, let me just see if I can just, let me just see. So this is what we are copying as the data path, right? Let me just Control C it. Okay, but you can notice that the backslash and forward slash are different. So when you come to set your working directory, let's say I just paste, I'll change that. Okay, we change it so that you can now show where to call from or to set your plots, your data. And then common practice when you're working in a directory, have your files for your data, your plots, what else? Okay, for data, you'll have that file, and then within the data, you'll also have other folders. You have your vector, you have your raster, you have your tabular, depending on what you're working on. Just try to organize your work so that it will be easier for you to call anything. Now, for example, I'm going to delete this, don't worry, but all of them are supposed to be facing. Let me just do it. Facing this way. Now, if you look at now this data folder, let me just click it. Within the data itself, I already have categorized into raster, then tabular, then vector. Now, this is what I was saying, try to arrange your work. And then within vector itself, you have the lines, the points, and the polygons. Let's go to, where is that data again? Let me delete this because I don't want to change the directory. Okay. So this is the install the packages function, but again, I already have mine installed. You can just uncomment them if you don't have it installed, then you can run it. Click run right here. So this will run this specific portion of code. Okay, let's comment it back again. Then let's run this part. Then you can see when I run it, I'm already shown that it's calling where the working directory is, where it's been directed to is in webinars. If I wanted it to go to data now, I'd use now the function I had written there, set working directory. And then now we have the initial loading for the tabular data. This is a library package that we're calling. We have read Excel because I want to read an Excel file right here. If I go to this path, right, I come here to my GIS data, and then I have my tabular data. You'll find that it exists, right? We have dummy data 01 shown there. So this is what I'm calling right here. I'm specifying the data path because I would have as well just used everything under data, which is fine. And then I'd specify the path within the working directory. But I just choose to use all of it together. So this one, you show where your path is. You use read Excel now to read now this variable data path, right? because it shows you where the path to where the data is. Then you use the Excel to now read the specific data that has been pointed to using the path. And then now I call print function, which will print now what's in our data. Okay, so what I'm using right now is the Markdown format because it's easier to show the code with the results themselves. So this was the data that has been shown. Let me open Excel. Okay. So if you can see this data, we have the species ID, species, temperature, humidity, all this. We have our data, oak, pine, all that, right? And then if you see, where is R? If you see R, you can see that it's also been called. You can see it has the species ID, species, temperature, humidity percentage is protected. We have all of it read into R, right? Then it shows now the number of rows that it can show. Let's see, library, read Excel. If I choose to say, let's say view, data 01, you can see that we have our data for the records here. The other one we called print function. We called print function, so it printed exactly here. Did not show all the rows, but you can still select to see all of it. I've used view now to show that we have this same data called from Excel. Let's say we look at the Cypress one, this one, 9211. You'll see where is Cypress right here, 15. This it's loaded, so you can tell that R has correctly loaded your tabular data. What else? View data. Okay, yeah, that's fine. And then you can also use, let's say, head function. Let's see, data 01. Let me remove view just because I've already used it. Okay, so when you're using head, it will show you the first 6. If you remember, we already used the print, and it shows that we have the 30 rows, right? But then if we use the head function, this one, if let's say you want to inspect your data for the first time and know what exactly is in it, which columns you have, which rows you have, you can use the head function to show the first 6 entries. Now imagine if someone has 1,000 records or 2,000, and then they just want to have the idea of what's in your data. You'll use that. Okay, what else? What else? I think that's it for the tabular data. Yeah. And then now we have the vector data. We have SF. I normally use map view when I want to use it in the viewer perspective. Hope that's fine. Let me maximize this. Yeah. So for the viewer perspective, you have your plots here, right? And then now this is viewer. So you'll find that when you're using map view, it will come to the viewer, this portion. I hope I'll have time to demonstrate that. Yeah, we might end a little bit later than was expected, but that's because we gave some time for us to join. Anyway, so we have now the soils data. As you had seen in the PowerPoint, then that was just initially loaded, showing gray. Let's run this, and then we have tmap, and then this function. Let me just run it first. Okay. So when you use now the stread function, you can see that the soils layer has been read, right? It's already shown you the path that we've read because again, this is what we had directed it to. Okay. And then now it shows it's a simple feature collection, IESF, with 3259 features, 31 fields. It's polygon. XY, then it also gives you the bounding box, i.e. the highest X, the lowest X, the highest Y, the lowest Y. Now think of it as if when you're using even a graph book, you can tell which extents something will lie in. So this is just basically what the bounding box, this line here, tries to tell you. And then now this is the data that we've loaded here from TMAP. So you can see we've loaded our soils data as we had shown in the PowerPoint. And then now we have the raster data. Let's see. Oh yeah, for the visualization for this, it's more of a process because now you have to look at the data itself. Let me see. Let me view this one. I want to see if we can look at the attribute table. Yeah, so as I was saying, when you look at vector data, you'll find that it has its attribute table. I've just changed this line. I've asked to view the soils so that I could look at the attribute table. So I've come here because when you use view, it opens another tab. You can see that the data has area, perimeter, the rainfall, I think this is bedrock, then soil drainage, the description. You can see that we have the different, if it's extremely slow, it's labeled E. If it's well, it's labeled W. We have a lot of records. You can see from here, we have 3,259. So if I were to scroll all this, I'll find that I still have all that data. And then again, you can look. So this is where we had, let me see if I can find that PowerPoint. Where are we? Okay. But if I share this, I'll have to toggle between R and that. I'll show you. I hope we can all remember the soils that we had visualized now with the different colors. We had the soil drainage description, this one. And then we also had was it the soil type? Yeah. I don't know why it's taking time to load, but it's fine. Let me remove this. And then now we have our raster data. Use the raster package for the art session. Again, we've shown where this raster data is. If you want to confirm that it's there, again, just come to your data, raster data. We already have the mean temperature, the TIFF file, this one. So that's what we are pointing to. Again, if we wanted to point to the vector data, we'll just change to whichever path. Let's say I'm going to the soils data. I'll look at this soils KE. I'll point to this shapefile. Okay. Data. Okay. Yeah. So we've called it, and then now this one will inspect the raster that we've loaded because we're just calling the variable. And then we'll call tmap to have a visual idea of what we're looking at. Here is some, I've called the tm shape function, again from tmap. Then the raster, change the palette to the brewer reds. There's a different palette. You can use different palettes, again, by inspection. And then I've said I only want to have 8 entries in my legend. It should be outside, not inside the map. And then again, I'll call it to view. So let me just run this. So first of all, we can look at this. We can see that we've loaded a raster layer. We have the dimensions, we have the XY, the extent, the coordinate reference system, i.e. the CRS, the source, i.e. what are we calling itself, the TIFF file, and then the name. And then you can also see that we have the values that we've been given for the min max, i.e. what is the minimum value I'm expecting to see in this raster? What's the maximum value I'm expecting to see in this raster? What else? Okay, yeah, that's that. So this is what had been visualized, right? Then you can see that it gave me the different entries. It gave me 0 to 1000, all that. Yeah. So I hope I've not changed too much here. Yeah. So here, I think this is why I had done the, yeah. So you can as well use R to do, what's this? Visualization. You can see that this was the data that we had loaded here from handling data. This is what we had loaded, right? So this specific script is only for raster data. I had separated them between the raster, polygon, tabular, but this one has the combination. That's why we constantly have to keep pointing to where we are calling the data from. If you remember, we've looked at how to call the tabular data, the vector data, and the raster data. So now you look at the raster data. I was explaining you'll have to remove some values. Again, you see that we've pointed. We're inspecting the raster. And then again, this is what we had seen. This is how we had stopped at. Where here. This, right? Then now we have the initial loading again. We've already seen this here in the combined script. So here is where we're talking about the threshold, right? You can see here I've made, okay, when you're doing scripting, best practice is to have some comments on it because you might understand what you're writing, but then someone else needs to have some explanation onto what you are doing, right? So we have here defining the temperature threshold to exclude water. Since water is below 0 degrees, it will be a consistent threshold. So now we have the temperature threshold set to 0. And then you set the values below this threshold to NA. This is what we've done here. Okay. You've seen that anytime I wanted to run any chunk, I pressed the run current chunk as we progressed. And then you repeat the plot with now the new range. Again, if you notice, we've not changed the brewer reds. We've kept everything constant, but you'll notice that there's a difference in how the map appears. So let me just toggle to this one and show this. This is what we're looking at. There's nothing that has changed here, except that now this temperature raster will exclude all values that are below 0. That was that. So here, if you look at the previous map, this one, no values had been removed. Like we had not applied any threshold, we had just called that data. But then here, we now applied the threshold, and now we have the mean temperature for the whole of Africa without now the outlier values for water. So you can see that it's better visualized. And then you can change your visualization to suit your specific needs. If you look at this, you can see that the north arrow is not placed as well as you'd want to. So now that comes to the aspect of how you arrange your elements. Let me see. Okay, yeah, I think, yeah. From how you arrange your elements, where is it? If you look at this part here of the script, you've just defined a few things. You've not necessarily played with anything under tmap, because now if you look, I'm calling tm shape, that's from tmap, tm raster again from tmap, tm legend again from tmap, right? So now we want to redefine the palette. You can see again we had this, we've just called it back so that you can see now where the difference comes in. We've used now, before we were using the brewer reds. Again, different palettes, you customize them according to what you would want to display or what you would want shown. So here we had used only the reds, and if you can see, we have only reds displayed, right? But then here you can see some yellow, orange. Now, this is where you change the palette. the brewer, the yellow, orange, red. Then we also added the title to be temperature in degrees Celsius, Africa. I think the other one we had not added it here. This one did not have the title. And then padding, you want your title to be bolded, the position of the title, the legend. Where do you want the legend to appear? Would you want it to appear left, center, right? Is it bottom? Is it top? So you can customize that as well. So for this one, we chose the center top. For the legend, it was the left bottom. Again, you just change your positions. And then now the compass shows arrow, the text size, showing labels. Yeah, so you can see this compass right here. And then now, when you're using TMAP, you'll find that sometimes you want to arrange it such that everything fits in perfectly, i.e. nothing is overlying something else, like this north arrow is directly on top of the map. So you'll call TMAP arrange. And then you call the previous map that you had just displayed. Where is it? Africa temperature. And then it will arrange for you and you'll get now your map. Again, you can play around with the data that you have with your specific visualization needs to get whichever, what's this, result or output that you want to obtain. So I think that's the end of the R demonstration, unless there's something I'm supposed to show here if anyone wants to see. But then let me stop sharing from R. Okay. I need a minute to switch. Okay. I'll have to share directly from my machine. Share this. Okay, hope we're good on time. Okay, so this is what why is it not displaying? So this is what I was showing on R. I've also shown how we had arrived to calling now this Kenya map. And then I've also shown for the tabular data. You've seen us calling the species data, how we had. You can also use the string functions to know now your specific data type. Like you can see this is numeric, character, logical functions, true, false, to inspect now your data. So we've already looked at the tabular, we've checked on the vector, we've also checked on the raster. I think, yeah, that's it. So this is just, it's not yet loaded for you. Oh yeah, so now this is just, I applied now the polygon again along a code, but for the Kenya boundary along a code, but again, you still end up with what you wanted to achieve. Now that's what I was saying, you can have for whichever purpose that you want to attain. For example, if I wanted to now do that raster and then mask with the polygon boundary, I've already achieved it. Again, longer lines of code, but you can still use R for geospatial data visualization analysis. If there are any questions, just drop them in the chat because now I'm winding up. We look at some of the trainings that we offer. We have the introduction to GIS. We have remote sensing as well, Google Earth Engine, ArcGIS Pro, QGIS, all of this that's listed here. If you're interested in more aspects of survey, more aspects of drones, more aspects of desktop GIS, programming, databases, we offer all of them here. So you can just keep in touch with us. Yeah, and then we'll be able to respond. So if we have any questions, if we have anything that, anyone who's not understood anything, any comments, can do that right now. We're good on time. Are we all good? Okay. Tom, is there any question in the chat? Or I was alone? Anyone who has a question, you can just raise your hand.
Anita,
Mm-hmm.
I don't think there is anyone in the question. It seems that everyone has understood everything.
Everyone has understood everything. Wow.
So maybe else we can ask a question. Where is it?
Okay, that's nice. So everyone has understood everything. Okay, I'll hand it over to Cutie if she's in a position to. But thank you for joining the webinar. Please contact us if you have any interest in any of our courses.
Anita, can you hear me?
Yes, Cutie, you're audible.
Okay, all right. So for the people who have joined us, thank you so much for joining today, and we hope you found value in the session. And we really can't wait to see how you apply these insights. We hope we could have gotten some questions, but that's okay as well. That shows that a good job has been done. But so on behalf of EcoSpace, we'd like to sincerely thank you for attending, and we appreciate your time. So should you have any questions or require further information, either about the courses, any suggestions, if you look out at our social media pages as well, you can check out our previous webinars. So kindly engage, and be on the lookout for any recordings and materials which will be shared with you shortly after this. Yes, so thank you so much, and we hope to welcome you again at future webinars. Thank you so much.
Okay, thank you, Cutie, and thanks for all of us who've joined. A slight note, we offer both online and physical trainings. So if it works for you to only have the online sessions, we can arrange that. And then if it works for you to have the physical or even hybrid, we can as well arrange that. Again, many thanks for joining. And we can leave in the next 5 minutes unless someone has anything else to say, but I'll leave the meeting open just in case there's something that crops up. But it will end at 4:25. Thank you. Thomas, you had something to say?
I just wanted to appreciate everyone who has joined the session, and us as EcoSpace. These are a chance for us to showcase our knowledge to you guys, and just keep in touch with us since there is more of this coming, and very insightful information will be shared to you via online and even physical in terms of training. Thank you once again, and back to you, Anita or Cutie, if you have anything to say.
Okay, thank you, Thomas. Again, thank you for joining. We can